Hello, good afternoon everyone. My name is Krzysztof Kabaczynski. I'm working for the company Be Optimized. The aim of the video is to continue the demonstration I started last time regarding the dynamic generation of SQL via LLMs. The problematic of last time was that it was difficult to guess the target datasets to use within SQL. So I found a solution. It's maybe not the best solution, but I found a solution to solve that problem. Let me first demonstrate how it works. So I'm here into SAS Enterprise Guide, working with SAS 9.4. I have a project. I have two codes. What's happened when I run the two codes? I have a question, a prompt. Within that prompt, I can specify a text. How many students are present in the classroom? And when I click run, I will get the answer. So two codes are executed. The first code allows you to guess what will be the input dataset. The second code will use that input dataset and will dynamically create the query. And the result is 19 students. Here I have a query, and here I have the transformation I'm doing in order to improve the context of my LLM prompt. How does it work behind the scenes? Basically, I have my question here again. It's quite difficult to specify the input data set. Here, you cannot do a like, you cannot make a contains, because the table is class. So it's quite difficult to create a real query if you want to determine that the target dataset is class. So what did I do? Basically, I'm using embedding. You know, when you are using LLM with RAG, you can do embedding. You embed some text in order to improve the context of your LLM. So that's what I did. More precisely, within the SAS help tables, you have plenty of them which have a label in their table name. So I created an export of all the table name and labels. Let me show you. Here it is. So basically, I have my table names of SAS help. I have here the label, and then I'm using this file in order to create embedding. So this code, the first code, is querying an API. Let me show you. It's querying an API with my question. My target is the library SAS help. That's the only information I provide. So the query has to guess from SAS help which table is the best in order to answer a question. So here is my my query, and then I create the table into a macro variable. Then the macro variable is used in the query I showed you last time. And that works perfectly, because here I specified how many students are present in the classroom. If I specify something else, how many cars exist in my table, something like this, the output should be normally the table cars, that's cars. If I go back, if I run again, give me the max population classified by region. What will be the table used behind the scenes? It will be demographic, and that's the correct answer. So the aim of this code is just to find the best table which can be used depending on my question. Okay, so let's now have a look at the code behind the scenes. So here I'm back in Visual Studio. I have here some Python code. Okay, if you want to extract the table class from the question how many students are present in the class, is not a piece of cake, because you cannot use contains, you cannot use like, you cannot use sounds like, you cannot use standard SQL clause. Instead, you can use a semantic search. How does it work behind the scenes? Suppose I have a text here containing my question. This is a test. The question here will be converted into a vector. And a vector is a mathematical representation of that text. So, here is my question with my vector. At the same time, here I have a list of all my tables with all my labels of the tables of SAS help library. So, what I did? First, I'm creating vectors for all the labels. I store them into a table, into a database. Second, when I make the query, I ask to convert my question into a vector. So, you have vectors, you have in your database other vectors. The last thing, you have to compare your vector with all the other vectors and extract the vector which is the most similar to the other one. In fact, behind you are doing a vector similarity search. You can do it using, in fact, LangChain. I've used LangChain because it's more easy. So, let's have a look to the code behind. Alors, for the story, I'm not using OpenAI or something like this. I'm using my local model stored on my laptop. So, here I'm specifying where is located my Excel spreadsheet containing the list of labels. Super. Here I have the definition of the embedding I want to use. I'm converting all my Excel spreadsheet into a format which can be used more easily by the Chroma database. Here I'm creating the vector store. Basically, here my Excel spreadsheet with all my labels will be converted into vectors and will be stored in that database. Okay? And finally, when I ask my query here, automatically, thanks to LangChain and Chroma, automatically my query will be converted into a vector, and all the vectors will be compared each other, and the best vector will be extracted. And because I specify that I want to get the name instead of an ID or whatever, I want to get the name as a feedback of my comparison, I get automatically the expected answer, which is the dataset class. I hope it will work. How many students are in the school? And the answer is the table class. Great, isn't it? Let's have a look back to Enterprise AI project. So the query you just saw before is encapsulated into a fast API application. Here is the endpoint. And now let's run it again. Hop, right click, run. Give me the max population classified by region. Okay, let's have a look. Max population classified by region. Not easy, eh? And that's the answer. Here is my SQL query, and that's the expected outcome. Okay, so thank you. Bye bye.